Dear student, Assalamu alaikum. Today, Bismillahirrahmanirrahim, class 9, subject physics, chapter number 6, work and energy. Topic of today's lectures are problem 6.5, 6.6, 6.7 till 6.10. We will discuss that are on page 142 of ninth class textbook. This is a chapter we are doing work and energy. Example, we have done 6.1 to 6.4. We have already done in my previous lecture. We have done 6.1 to 6.4. But today we will discuss about 6.5, problem number 6.5, which is on page number 142. If you open 142 page of my class textbook, you will find this problem 6.5. We are going to solve 6.5 problem. I repeat 6.5 problem statement. On reaching the top of a slope 6 meter high from its bottom, a cyclist has a speed of 1.5 meter per second. Find the kinetic energy and the potential energy of the cyclist. The mass of the cyclist and his bicycle is 40 kilograms. I repeat 6.5, problem number 6.5, which is on 142 page. On reaching the top of a slope 6 meter high from its bottom, a cyclist has a speed of 1.5 meter per second. Find the kinetic energy and the potential energy of the cyclist. The mass of the cyclist and his bicycle is 40 kilograms. First of all, we write the given data. The height is given to me, which is 6 centimeter. The height is given to me 6 meter, and the speed is 1.5 meter per second. Speed is given to me 1.5 meter per second, and mass is denoted with small m, which is also given to me 40 kilogram. And as you know, the value of acceleration due to gravity is g is equal to 10 meter per second square. Because the cyclist is going at the top of the slope, so that's why g will be involved. G is equal to 10 meter per second square. If it is not given to you, then you should memorize this by heart. Acceleration due to gravity is G equals to G. G is equal to 10 meter per second square. We have discussed so many times the value of G is 10 meter per second square. So kinetic energy we need to find out, and the potential energy in this numerical we need to find out. Kinetic energy is denoted with Ke, which is we need to find out, and potential energy Pe we need to find out. You know the formula for kinetic energy is half mv square. I have already discussed in 6.1 till 6.4 numerical. We find kinetic energy. When we find kinetic energy, I use this formula half mv square. So just putting the values, mass is 40 kilogram and v is 1.5 whole square. So if you multiply this, so that is 20 multiplied by 1.5 square is 2.25. If you multiply 2.25 with 20, it's gonna be 45 joule. The kinetic energy is 45 joule. The first thing we have found. Now I'm moving towards potential energy. Potential energy is the formula for potential energy is mgh. So when again putting the values, m is 40, G value of G is 10, and height is 6. So if you multiply this 40 multiplied by 10 multiplied by 6, you will get 2400 joule. So potential energy will be 2400 joule. So two things are required in this numerical: kinetic energy and the potential energy. Kinetic energy is 45 joule and the potential energy is 2400 joule. So we have found the first 6.5 numerical on page number 142. Now the result will be kinetic energy is 45 joule and the potential energy is 2400 joule. Now I'm moving towards 6.6 numerical. 6.6 numerical is, I read the statement first for you. A motorboat moves at a steady speed of 4 meters per second. Water resistance acting on it is 4,000 Newton. Calculate the power of its engine. I repeat, 6.6 on page number, numerical 6.6 on page number 142. The numerical statement is as a motorboat moves at a steady speed of 4 meters per second. Water resistance acting on it is 4,000 Newton. Calculate the power of its engine. We need to find the power in this numerical. So speed is, I'm going to write the given data. Speed is V is equal to 4 meters per second, and the water resistance is denoted with capital F, and which is also given to be 4,000 Newton. In this numerical, what is asked? Asked is power. Power is denoted with capital P. So you know the power formula of power is equal to W by T. Power is equal to W by T. Rate of doing work is called power. And W is equal to Fs. Work done is equal to force times distance. We have already discussed this formula in our previous lectures. Fs divided by T. So you know S by T is the formula. V is equal to St. By using this formula, S by T is equal to V. So F times V. So S by T is equal to S by T is equal to V. So our the power will be F times V. Just put the values. Force is 4,000. Multiply by V is given to me 4. If you multiply 4,000 with 4, you will get 16,000. And the unit of power is watt. 10 is to the power 3. You can write 1, 2, 3. How many zeros? 3 zeros. So 10 is to the power 3 is kilo. So 16 kilowatt is my required answer. Result will be power. Power is equal to 16 kilowatt. I repeat this numerical. A motorboat moves at a steady speed of 4 meters per second. Water resistance acting on it is 4,000 Newton. Calculate the power of its engine. What is given to me? Speed. Speed is denoted with V, and it is given to me 4 meters per second. Water resistance, you know the unit of Newton is a force. Force, water resistance, F equals to 4,000 Newton. To find, we need in this numerical, we need to find power, and the formula for power is the work, rate of doing work is called power. So P is equal to W by T. W is the work done, and T is the time. So work done, you know the work done, the formula for work done is F times S. So work done is equal to Fs divided by T. And you know the formula S by T is equal to V. V is equal to St. V is equal to S is equal to Vt. This is the formula. So I arrange this formula. V is equal to S by T. Just S by T replace S by T with V. And then plug in the values. 4,000 multiplied by 4. 4,000 is force and V is the 4. So if you multiply 4,000 with 4, you will get 16,000. And the unit of power is watt. So I need to convert this into kilo. So how will I can how many zero? 1, 2, 3 0. So I can write 10 power 3 watt. So 10 power 3 is kilowatt. So power is equal to 16 kilowatt is my required result of problem number 6.6. Now I'm moving towards problem 6.7. First of all, uh, I read the statement, problem 6.7 statement. A man pulls a block with a force of 300 Newton through 50 meter in 60 seconds. Find the power used by him to pull the block. I repeat, problem 6.7 on page number 142. Please open page number 142 of your textbook, and problem number 6.7 I'm going to solve now. Statement of the problem 6.7 is a man pulls a block with a force of 300 Newton through 550 meters in 60 seconds. Find the power used by him to pull the block. First of all, I write the given data. Force is given to me 300 Newton, and then distance is given to me 50 meters, and the time is 60 seconds. In this numerical, we are asked to find the power. So you know the power formula is W by T. As we discussed this power formula in the last numerical. 6.6, we discussed the same formula. We use the same formula. Power is equal to W by T. The rate of doing work is called power. And W is equal to, and you know W is equal to Fs. As we discussed the work done, Formula for work done is W is equal to Fs. So I replace W with Fs. Fs divided by T. Just putting the values. Force is given to me 300. I just force is 300. Distance is 50. And time is 60. Just plug in the values which are given to you. And then solve this. 300 multiplied by 50 divided by 60. You will get 250 watt. The power result will be power. Power is equal to 250 watt. I repeat this numerical for you for your convenience. A man pulls a block with a force of 300 Newton through 50 meter in 60 seconds. Find the power used by him to pull the block. So what is given to me? Just write the given data. Force F is equal to 300 Newton and distance S is given to me 50 meter, time is 60 seconds. These three things are given to me. In this numerical, I need to find out power. So formula for power, as we discussed when we read the chapter, when we study the chapter number 6, we at the end of the chapter, we discuss this formula. Rate of doing work is called power. Power is equal to W by T. And you know work done is equal to Fs. Just put work done is equal to Fs divided by T and then plug in the values. Force is 300, force is 300, distance is 50, and then time is 60 seconds. If you multiply 300 with 50 divided by 60, you are going to get 250 watts. And the result will be power is equal to P, and which is 250 watt is the required answer of problem number 6.7. Now I'm moving towards problem number 6.8. Problem number 6.8 is I read the problem 6.8 statement first for you. A 50 kilogram man moved 25 steps up in 20 seconds. You can see the figure, okay, in 6.8. Underneath the statement of the numerical 6.8, you can see the man is moved 25 steps up in 20 seconds. Find his power if each step is 16 centimeter high. I repeat, a 50 kilogram man, the mass of the man is 50 kilogram, and the stairs have 25 steps, and he covers 25 steps in 20 seconds. Okay, find his power if each step is 16 centimeter high. The distance from one step to the other step is 16 centimeter. Okay, now I write the given data. Mass is known to be small m, which is mass of the man is 50 kilogram, and number of steps he is going to cover, n is denoted, I take it as n is equal to 25 steps. These are the steps of the stair steps, 25 steps. The stairs have 25 steps. The time is given to me 20 seconds. He covered 25 steps in 20 seconds. Okay, height of each step is 16 centimeters. Since this is in 16 centimeters, so we need to convert this into meter. As you know, the distance unit is meter. The SI unit of distance is meter, or height is meter. Height is also a distance, so its SI unit is meter. So how I convert this 16 divided by 100, you can convert this into meter, which is 0.16 meter. The other things are in SI unit already. Mass is already in kilograms, so we don't need to convert this into anything. Or time is given to us in second already. We don't need to convert this. These are all already in SI units. So only thing we need to convert is height, which is 16 centimeter. That's why I divide 16 divided by 100. It's gonna be 0.16 meter. The only thing you converted is LSI is height. In this numerical, we are asked to find power, and power is denoted with P. And you know the formula for, F is equal to W and W is equal to mg. Because the formula for power is equal to FD divided by T. How? Work done is equal to P is equal to W by T. W is equal to F times D, right? The distance, F times D. You know the work done formula is F times D. So how I convert force? Because force is not given to me. That's why I use the formula F is equal to W, W is equal to mg. My mass is 50. I already put it mid 50 or value of G is 10. So if you multiply this, you have converted this into Newton. Force is 500 Newton. We have 50 multiplied by 10 is 500 Newton. Again, we have 25 steps and each step, the height between one step to another is 0.16 meter. So we convert this 25, if we multiply 25 multiply by 0.16, if he has covered, the man has covered 4 meter distance, right? The power formula is FD divided by T. The power formula is W by T, but W is equal to F times D divided by T. So if I am just putting the values 500, 500 is the force, and D is 4 meter, and time is 20 seconds, which is given to me. If I multiply this 500 multiplied by 4 divided by 20 with the help of calculator, you can find the power, which is 100 watt. The unit of power is watt. So my result will be power. Power is equal to 100 watt. I repeat the numerical 6.8 numerical. Now, a 50 kilogram man moved 25 steps. 25 steps up in 20 seconds. Find his power if each step is 16 centimeters high. You can see the figure. A man is moving up, and he's covering 25 number of steps of the stairs. Mass M is given to me 50 kilogram, and number of steps he has moved N is equal to 25. Time is given to me 20 seconds, and height of each step is 60 centimeters. The height of one step to the other step is 16 centimeters. First of all, I convert the rest of the things are in SI. Mass is in SI. So the unit of mass is kilogram, which is SI unit, and time unit is second. This is already in SI unit. So only thing we need to convert this in SI is centimeter. We need to convert this into meter because the unit of height is meter, which is the SI unit. So 16 divided by 100, it's 0.16 meter. So to find power, power is equal to P. We need to find out before finding this power. First of all, we will calculate the few things before calculating the power. So you know the force is not given to me in the numerical. So I can use this formula F is equal to W and W is equal to mg. And you know mass is 50 and G value of G is 10. This is understood value. So 50 multiplied by 10, you will get 500 Newton. Again, one step, number of steps he covered, the man covered number of steps, 25 steps, and each step has height 0.16. So 25 multiplied by 0.16 is 4 meter. This is the total distance covered by a man from one step to another step of the stairs. So power is equal to FD divided by T. The formula for power is rate of doing work, W by T, and W is equal to F times D divided by T. So 500 multiplied by 4. Force is 500. I just found it. And D is D is 4 meter. So time is 20. If you multiply and then divide with 500 multiplied by 4 divided by 20, you are going to get power is equal to 100 watt. So power unit is watt. So my result will be power. Power is equal to 100 watt. Now I'm moving towards 6.9 numerical. Very easy numerical. 6.9. First of all, I read the statement. Same formula we are using again and again. Power is equal to W by T. You should be very careful when doing this, right? So calculate the power of a pump which can lift 200 kilograms of water through a height of 6 meters in 10 seconds. Mass is given to me 200 kilograms. So this is already in SI unit. Height is 6 meters is also given to me, and time is 10 seconds, and G value of G you know 10 meter per second square. Acceleration due to gravity value is 10 meter per second. In this numerical, we are asked to find power. Then power formula is P is power, but power is equal to W by T. You know this W by T, work done by rate of doing work is called power. So when we discuss the chapter number 6, we study this formula, power is equal to rate of doing work. P is equal to W by T. And you know W is equal to Fs. Since he's lifting, since the pump is lifting, that's why S is replaced with H. S is replaced with H. So W is equal to FH. You can write W is equal to FH divided by T. And you know F is equal to W and W is equal to mg. You know this. F is equal to W and W is equal to mg. So I am putting F is, F is equal to W. So I replace W, F with W, and W times H divided by T. So you know W is equal to mg. I have already told you. Mg or this H is already there. So divided by T, just plug in the values. Mass is 200, it's given to me, and G is 10, and height is 6, and divided by time is 10. If you multiply by 200, multiply by 10, multiply by 6, and then divide by 10, you will get 1200 watt, and power will be 1200 watt. I repeat, numerical 6.9 for you for your convenience. Calculate the power of a pump which can lift 200 kilogram of water to a height of 6 meters in 10 seconds. Students, you need to write just whatever is given to us. So in this numerical mass is given to me 200 kilogram. So this is already in SI. We don't need to convert this. And height H is 6 meter. This is also given to me. And time T is 10 seconds. So G is 10 meter per second square. G is 10 meter per second square. And you know the value of G, that is understood value. G is equal to 10 meter per second. If it is not given to me, you should memorize this by heart because we are going to use this value in our numericals. So power is equal to W by T. You know the formula for power, as I discussed so many times. Power is equal to rate of doing work, W by T, and you know W is equal to F. F is equal to W. W is equal to M. So you replace F S W is equal to F S. S, since this is the height, so S is replaced with height H. So W times H, I can write F is equal to W, W times H, and you know W is equal to mg. So just putting the values, W is equal to mg times h, and then put the values. M is 200, it is given to me, and G is 10. G is given to me 10 meter per second, and height is 6 meter, and time is 10 seconds. So if you plug in all the values and solve this with the help of calculator, you will find the power which is 1200 watt, and the unit of power is watt. So our required answer is power 1200 watt. Now I'm moving towards last numerical of this chapter. Then after this, our numerical has been ended. 6.10, this is the last numerical of this chapter, number 6. I read the statement first. An electric motor of 1 horsepower is used to run water pump. The water pump takes 10 minutes to fill an overhead tank. The tank has a capacity of 800 liters and height of 15 meters. Find the actual work done by the electric motor to fill the tank. Also find the efficiency of the water of the system. Okay, so I'm going to solve this from this one. You know, power of the motor is 1 horsepower, and you know 1 horsepower is equal to 746 watt. We have already discussed. Then we discussed the power formula. When we discussed the power topic power, studied the topic power, and topic power we discussed 1 horsepower is equal to 746 watt. If you are not sure how where it is coming from, you can if you open the page number 137 under the topic power, you will find 1 horsepower is equal to 746 watt, which is on page number 137. Time is given to me also 10 seconds, 10 seconds, 10 minutes, sorry. So 10 minutes is not the SI unit of time. So we need to convert into SI, and the SI unit of time is second. So how will, in 1 minute we have 60 seconds. So 60, if you multiply with 60, multiply by 10, you can convert this into second, which is the SI unit of time. Tank capacity is given to me 800 kilogram, or height is also given to me 15 meter. So in this numerical, we are asked to find work done, and work done is not with W. and efficiency. Two things are required in this numerical: work done, W, and efficiency. Percentage efficiency we will find out, right? We know the formula for power is equal to P is equal to W by T. This is so many times I have used this formula, and I have told you the formula of power is rate of doing work is called power. So power is equal to W by T. So you need to find out the work done. So cross multiply. So W is equal to P times T. P multiplied by T, you will tell W. So just plug in the values. Power is 746. Power is 746, and time is 600. If you multiply 746 multiply by 600, you will get 44,7600 joule. Again, this is the actual power done, right? This is the actual power. Now this is the energy given by motor to fill the tank. Now the work done to fill the tank is potential energy. So because we are filling the tank, so it's mean we are pumping the water onto the tank. So the energy stored in the tank will be potential energy. So water has a potential energy. So work done is equal to PE, P is equal to mgh. Just plugging the values: 800, mass value is 800, and G value is, you know, the value of G is 10 meter per second, and height is 10, and height is 15. If you multiply this, work done will be 1,20,000 joule. So this is the actual work done, and this is the input. One is input, one is output, right? You know the definition. This is the continuation of 6.10 numerical. Efficiency is output divided by input multiplied by 100. So efficiency is 1,20,000. Our output is always less than the input, right? So 1,20,000 output divided by input is 44,7600, multiply 100, because you are going to find out the percentage of. Student, I forgot to write percentage over here. You need to write percentage over here, where I am pointing my cursor. So output divided by input multiplied by 100, you will get 26.8%. So our percentage efficiency is 26.8%. Actual work done is, we just found 44,7600 joule, as I discussed earlier. This one is the actual work done, 44,7600 joule. And what else we find? We found the efficiency 26.8%. I repeat numerical 6.10. An electric motor of 1 horsepower is used to run water pump. The water pump takes 10 minutes to fill an overhead tank. The tank has a capacity of 800 liters and height of 15 meters. Find the actual work done by the electric motor to fill the tank. Also find the efficiency of the system. So what is given to us, I'm going to write. Power of a motor is 1 horsepower, and 1 horsepower I have already told you 137 page. Under the topic power, you can find this formula: 1 horsepower is equal to 746 watt. And time is given to me in minutes, so I converted this into second, because the unit of time, SI unit of time is second. So 60 multiplied by 10 is 600 seconds. Next, tank capacity is given to me M. M is equal to 800 kilogram, right? So height is H is 16 meters. So in this numerical, we are required to find work done and the efficiency. So you know the power formula of power is P is equal to W by T. Since I want to find out the work done, so I cross multiply this. So W is equal to P times T. So you know the power is 746. 746 multiplied by time is 600. If you multiply this, you will get 44,7600 joule. So this is the input power, actual power given to the tank, water tank. So this since we are storing the water, since we are pumping the water on the overhead tank, that's why the water carry the potential energy. So W is equal to PE, P is equal to mgh. M is 800, M is 800, G is 10. You know the value of G is 10, and height is 15 given to me. So if I multiply this, I get 1,20,000 joule energy. This is the input and output energy. So output energy is always less than the input energy. So in order to find out the efficiency, percentage efficiency, you need to write percentage over here. So a formula for a percentage efficiency is output divided by input multiplied by 100. So output divided by input multiplied by 100. So output is, I just found 1,20,000, and input I given to the system is 44,076, 44,7600 multiplied by 100. So if you solve this, if you divide this and then multiply by 100, you will get 26.8%. So our actual work done will be W 44,7600 joule, and our efficiency is 26.8%. So this is the end of the chapter number 6, numerical. Students, I hope you understand. If you have any question regarding these numericals we discussed, the numerical we discussed today, please feel free to ask questions. Thank you. And your homework is practice problems of chapter number 6 as we are doing one time on rough resistance and then transfer them on lead resistors. I will check only lead resistors, right? Practice problem of chapter number 6 that which we are doing. This is your, first of all, try to practice them on the rough resistor, and then when you are good solving this numerical by yourself, then transfer them on the lead register. I will check only the lead register. Okay, thank you. If you have any query, any questions regarding today's numericals, please feel free to ask us. Thank you. I'm here. I will be I'm waiting for your questions. Thank you. Please unmute your mic and ask us. Yes, please. Usman, Usman Yunus, Sam, any question? Please unmute your mic and ask question. Please. If you have any question regarding today's lecture, please feel free to ask questions. Thank you. I'm waiting. Marinisa.